Classification is technique to categorize our data into a desired and distinct number of classes where we can assign label to each class. Classes are sometimes called as targets/labels or categories. Classification predictive modeling is the task of approximating a mapping function, f, from input variables, x, to discrete output variables, y. Applications of classification are speech recognition, handwriting recognition, biometric identification, document classification, etc.
Classifiers types, binary classifiers, classification with only two distinct classes or with two possible outcomes. For example, male and female. Classification of spam email and non-spam email. Classification of author of book. Positive and negative sentiment. Multi-class classifiers, classification with more than two distinct classes. For example, classification of types of soil. Classification of types of crops. Classification of moods in music. Types of learners in classification. 1. Lazy learners. Lazy learners simply store the training data and wait until a testing data appear. When it does, classification is conducted based on the most related data in the stored training data. Compared to eager learners, lazy learners have less training time but more time in predicting. 2. Eager learners. Eager learners construct a classification model based on the given training data before receiving data for classification. It must be able to commit to a single hypothesis that covers the entire instance space. Due to the model construction, eager learners take a long time for train and less time to predict.
Classification algorithms. There is a lot of classification algorithms available now, but it is not possible to conclude which one is superior to other. It depends on the application and nature of available dataset. For example, if the classes are linearly separable, the linear classifiers like logistic regression, Fisher's linear discriminant can outperform sophisticated models and vice versa. 1. Lazy learners. K-nearest neighbor, KNN. KNN classified an object by a majority vote of the object's neighbors, in the space of input parameter. The object is assigned to the class which is most common among its K, an integer specified by human, nearest neighbor. It is a non-parametric, lazy algorithm. It's non-parametric since it does not make any assumption on data distribution. The data does not have to be normally distributed. Case-based reasoning, CBR. Case-based reasoning, CBR, broadly construed, is the process of solving new problems based on the solutions of similar past problems. For this method to work, a distance metric is required that measures the closeness of two examples. First, define a metric for the domain of each feature, in which the values of the features are converted to a numerical scale that can be used to compare values. Case-based reasoning, CBR. An auto mechanic who fixes an engine by recalling another car that exhibited similar symptoms is using case-based reasoning. A lawyer who advocates a particular outcome in a trial based on legal precedents or a judge who creates case law is using case-based reasoning. So, 2. An engineer copying working elements of nature, practicing biomimicry, is treating nature as a database of solutions to problems. Case-based reasoning is a prominent type of analogy solution making. It has been argued that case-based reasoning is not only a powerful method for computer reasoning, but also a pervasive behavior in everyday human problem-solving, or, more radically, that all reasoning is based on past cases personally experienced. 2. Eager learners. Most used classification algorithm. Decision tree. Decision tree builds classification or regression models in the form of a tree structure. It utilizes an if-then rule set which is mutually exclusive and exhaustive for classification. The rules are learned sequentially using the training data one at a time. Each time a rule is learned, the tuples covered by the rules are removed. This process is continued on the training set until meeting a termination condition. The tree is constructed in a top-down recursive divide-and-conquer manner. All the attributes should be categorical. Otherwise, they should be discretized in advance. A decision tree can be easily overfitted, generating too many branches and may reflect anomalies due to noise or outliers. An overfitted model has a very poor performance on the unseen data even though it gives an impressive performance on training data. Naive Bayes. Naive Bayes is a probabilistic classifier inspired by the Bayes theorem. Under a simple assumption which is the attributes are conditionally independent. The classification is conducted by deriving the maximum posterior, which is the maximal piece of vertical bar x, with the above assumption applying to Bayes' theorem. This assumption greatly reduces the computational cost by only counting the class distribution. Naive Bayes is a very simple algorithm to implement and good results have obtained in most cases. It can be easily scalable to larger datasets since it takes linear time, rather than by expensive iterative approximation as used for many other types of classifiers. Naive Bayes can suffer from a problem called the zero probability problem. When the conditional probability is zero for a particular attribute, it fails to give a valid prediction. This needs to be fixed explicitly using a Laplacian estimator. Artificial neural networks. Artificial neural network is a set of connected input-output units where each connection has a weight associated with it, started by psychologists and neurobiologists to develop and test computational analogs of neurons. During the learning phase, the network learns by adjusting the weights so as to be able to predict the correct class label of the input tuples. There can be multiple hidden layers in the model depending on the complexity of the function which is going to be mapped by the model. However, when there are many hidden layers, it takes a lot of time to train and adjust weights. The other disadvantage is the poor interpretability of model compared to other models like decision trees due to the unknown symbolic meaning behind the learned weights. But artificial neural networks have performed impressively in most of the real-world applications. It is high tolerance to noisy data and able to classify untrained patterns. Usually, artificial neural networks perform better with continuous valued inputs and outputs. Comparing to most used classification algorithm. Decision tree versus k-nearest neighbor, KNN. Decision tree is simple to understand and visualize, requires little data preparation, and can handle both numerical and categorical data. On the other hand, k-nearest neighbor algorithm is simple to implement, robust to noisy training data, and effective if training data is large. If we talk about both algorithm disadvantages, decision tree can create complex trees that do not generalize well, and decision trees can be unstable because small variations in the data might result in a completely different tree being generated. K-nearest neighbor algorithm need to determine the value of k and the computation cost is high as it needs to compute the distance of each instance to all the training samples. Comparing algorithm datas. Visualizing data with decision tree. Visualizing data with KNN.